Okay, now we move to the next slide, next topics. That is about dynamic games. I mean, we've learned the basic stories about normal phone game, but there is also other types of game. By the way, when we are doing this, I mean, at the beginning of the semester, I tried to, uh, we tried to take a midterm exam. But as I said, it's better for you to write a kind of a small short paper, not a paper, it would be more proposal instead of solving the, the questions here. So I ask you guys write a small short proposal, just I mean, maybe 3 or 4 pages, that's enough for you. But the only rule here is to use the game theory. Maybe you can use uh, normal phone game or something that you're gonna run here. I mean, with using dynamic games of complete information stuffs. So, but anyway, I mean, only required rule is to use normal form, I mean, game tool. Then it's okay. Then um, you can come up with any kind of idea. So um, maybe until next week, I'm going to ask you to submit me just one page proposal of using that. In order to do that, I'm giving you, I mean, maybe next week, I'm giving you some paper list. It may be helpful for you to uh, mix your idea with the game tool. But anyway, so but to make you understand what's going on about this game theory, I'm giving you some quizzes for that. I mean, to make you understand the stories. But beside, I'm giving you, I'm asking you to submit me uh, a proposal at the end of the semester. That's my plan. Anyway, what we are going to do is about dynamic games of complete information. What is it? Its definitions like that. Um, Previously, when we were doing a normal form game, we uh, it 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 was composed of 3 components. One is the player, the second one is a strategy, and the other one is payout. But here, one thing is added, that is that order. Every player has an order of when to decide one's action. What it means, when one decide to one's action, I mean, they will have, now they have an order. Previously, when they decide one's action, they didn't know what kind of strategy the others chose. But here, each player has an order. So one player um, has an order. One player will know what kind of strategy the others chose. Okay. Also, there is a pay-up function. Players know another players pay-up function. The players with the move knows the full history of the play so far. I'm going to explain this part later. In other words, I mean, now we are considering a game in which, I mean, when players try to choose an action between players, they have an order. Previously, we didn't have any orders, but here players have an order. That's the only main difference between dynamic game and normal phone game. So to represent this dynamic game, we usually uh, are going to use a graph. So this graph consists of a node, and branch. What is a node? Basically, a node is a point. It is represented by a point, and this node represents a player who is going to choose an action. That is the time for that player to choose a player. So this node let us know who is going to choose an action. Okay, but among nodes, there are some different kinds of a node. The first node that game start with is called the initial node, or called root. The first node, or the first player who chooses an action, that's root, or that's an initial node. Terminal nodes represent that is an outcome. The last nodes, or nodes that no player has another move, that's terminal node and outcome. Branches in actions that are available to the current player. So once one player is at the node to choose an action, the player will face several choices that this player can choose. That choices are represented by branches. So actions that are available to the current player, that branches are actions, represent an action. So I'm giving you an example. It will be more easier for you to follow by looking at that example. So, well, this is called a game tree. This game tree represents a game. Previously, we usually represent a game by a table. The reason why we use the table is because at the time, we didn't have any time concerns, because everyone starts their action simultaneously, so that they don't need to choose. We don't need to who is going to choose first and later. But here in dynamics game, we decide we need to see who is going to choose first and later. That is represented by a game tree like this. Okay, so if we look at this tree, actually there should be a kind of pointer like that. This point, the nose. These are nose. Again, nose usually represent who is going to choose an action. Here, the first player 1, is going to choose an action. This nose represent that. Then this nose, player 2 will choose, his or her action. At the same time, this node is an initial node, because the game is started from this initial node. I'm going to use this initial node. Okay, and I'm doing this, and this one, and this one, and again this one. This node is called terminal node. Okay, terminal node, at the terminal nodes, this node just tell us what is the outcome, not telling us who is going to choose one's action. It does not tell us that, but initial node is telling us, and nodes which is not the terminal node tell us who is going to choose an action. So here, the first player is going to choose one's action. Okay, and we call this is branch. These are branch. So this branch represents what kind of action that, the player on the previous nodes can choose. So here, P1 means at this node, also that is an initial node, the first player will choose what kind of action this player will choose between left and right, L and R. So player 1 can choose at the initial node L or R as a branch. If the first player chooses L, then we are here and the game ends. And player will get the payout. The first player will get 2, the second player will get 0. If the second player will choose, if the first player choose all, then the game proceeds and the second player will face the time that the second player can choose between L or all. If the second at this node, the second player can choose between L prime or R prime. If the second player chose L prime, then the game proceeds to this direction and the game ends. What they will get is 1 and 1 as a payout. If the player 2 chose R prime, then they will get 0, 2. This is the first player's payout. This is the second player's payout. Okay? So again, what's different from a normal form game is that in this game, there is an orders. First player will choose his or her action first, and then if this node is reached, then second player has a right to choose his or her own action. Okay, if the first player chooses left from the beginning, then this game will proceed to this direction and the game will end. Okay, now look at another game. Well, even though I hear just 1-to-1, I should put a more longer name to represent which player is playing. So it should be P1, it should be P2, it should be P1 again. Even though there is a circle, one point here, it should be. So these are nodes. Okay, these are nodes. And I will say, this node is an initial node again. Initial nodes, because at this nodes the game starts, and these are terminal nodes because once the player reaches these terminal nodes, the game ends, and player will receive their payout. Okay, so these are terminal nodes. Although except the terminal nodes, the remaining nodes is just nodes in which player will choose their own action. Again, this game starts by the first player's action. The first player will choose L between L or R from the initial node. If the first player will choose L, if the first player chooses L, then this game proceeds to this direction and the game is end. If the first player chooses to R, then the game proceeds to the right and they will reach it to that point, and the game will, the second player can choose between L prime or R prime. Once the game is reached to that node, if the second player chooses L prime, the game will proceed to this direction and the game ends. If the second player choose to R prime, then this game proceeds to this direction and they will reach to this node. And once that node is reached, then the first player will choose between L prime or R prime, and if the second player and the first player again choose the L double prime, then they will go to this direction and the game ends. If the first player chose R double prime, then they will go to this direction and the game ends here. And so again, this is another game of three. First, the game started by first player's action, and its first turn, and the second turn, if this node is reached, then the second player can choose. And if the second player chose R prime, then this node is reached, then the first player again can have a chance to choose between L prime and R prime, and then game goes like that. So what we can see here is that at this node, I will call this as node A, B, and C. Between these nodes, there are time differences. So once this, for example, once this node is reached, then from this node, based on this node, this node is past, and this node is future. But once this node is reached, previous two nodes represent what the player chose in the past. Okay? But at the initial node, what will be happened in these nodes, if I'm standing here, then these two nodes, what this player will choose in the future, there are future, not the past, because it's not happen when the player one is choosing his strategy at the initial node. Okay, so as we can see, the point here is that because there are order between players choosing, what they can do here, it's like there are time is passing from here to the future as day goes. Okay, so this dynamic game basically can be resonated with time. That's one thing I'd like to tell you. Still, we are defining what is the game, the dynamic game. Sometimes we call extensive form game versus normal form game. Okay, what we've learned was a normal form game, and this is called extensive form game, or a dynamic game. Already I explained dynamic game because there is a time differences. Okay, extensive form game, normal form game, or dynamic game. So anyway, now, as before, we need to see what is the strategies. In a normal form game, it was very simple because they don't have any time differences and orders. Each player just choose where to go, where to choose. That's it. That's the strategy. Extensive form game, we also need to find what is the strategy. We will define, this definition is the same for normal form game and extensive form game actually. But here we formally define what is the strategy. Strategy is the complete plan of action for each contingency. So basically, if something will be happened, for that situation, I need to prepare what kind of action I'm going to choose if that something is happened. So that is a strategy. Strategy is the complete plan of action for each contingency. That's a strategy. So if you come up with a kind of military action, in a military action, something happens, or maybe something A situation can be happened, or B situation can be happened, C situation can be happened. In that situation, we don't know yet before making a plan. Players should have kind of, contingency action. If A is happened, then I'm going to play this, D, for example. If B is happened, I'm still going to choose D, but C is happened, I'm going to choose F, for example. I will choose those kind of strategy. That is kind of military action. Even though one of the three actions will be happened, and the other two, the preparation for the other two actions is a kind of redundant in some sense, but military action is some kind of construct, the whole kind of action that players can choose for every kind of situations. That is a contingency plan. So that is the strategy. So going back to the previous cases. So look at this. First player's strategy is this. Okay, if I'm going to choose L or R, right? So I'm going to choose L or R. That is my strategy set. For the player B, I don't know whether this node will be reached or not, but once this node is reached, I'm going to choose between L prime or R prime. That is second player's strategy. That's simple, okay? But look at this. Well, first player will choose like that, okay? Once the game started, first player will choose between L or R. If R is reached and this node is reached, then L prime or R prime, player 2 can choose between L prime or R prime, okay? And think about that. If this node is reached, I don't know from the first player's perspective whether this node is reached or not. First player cannot know, before game is started. But if this node is reached, then first player will choose between L prime or R prime. This is the strategy set. So think of what other strategy. For the second player, this will be a strategy set for the second player. However, the first player, the strategy set will be something like that. It's a strategy because a strategy is the complete plan of action for the players when something's happened. So it will be represented by this sense, okay? If this node is reached, that is a sure thing. But anyway, I'm going to choose L. But if this node is reached, then I'm going to choose L double prime. That will be a kind of a strategy for the player 1. Why? Again, what is the strategy? Strategy is a complete plan of action for each contingency. Again, these are contingency. This is his action when this node is reached, but this is the first player's plan if this node is reached. Actually, there are more kinds of strategy that player 1 can choose. Even though first player can choose this, but if this node is reached, maybe this player can choose R double prime. Okay. Also, maybe from the first node, well, in some sense, this is ridiculous because if once the player 1 choose L, then all the other thing will not be happened. So the possibility that player 1 can choose at this node is 0. However, if this is a kind of military action, even though he tried to choose L once the game is started, because of some kind of reason, maybe, I mean, I don't know, but because of some kind of error or maybe because of the fool, maybe the first player may choose R, even though the first player has a willingness to choose L. Then this node may be reached. I mean, the first player just tried to prepare that kind of weird situation. So even though when the first player has a willingness to choose L from the beginning nodes, I mean, in that case, it will be very low probability that the first player can choose something at this node, right? But this player tried to prepare something, expecting that maybe this node maybe is reached. Then the first player tried to choose R prime. Also, there are more cases. First player can choose R, but here can choose L double prime or maybe R and R double prime, right? It's like there are 4 strategies are possible for the first player, okay? So, again, second player's strategy set is all L prime and R prime. But first player's strategy here is L or R, and we use this symbol to find the Cartesian product. Here, the first player will choose L prime or R prime. And this is the same as this. The Cartesian product is picking up one member in each set. So L and L double prime, comma, there are 4 the other strategies there, and here R and R double prime. So there are 4 members, and this is the first player's strategy set. Okay, so I'm giving you another example to make you understand more deeply. So how about this? I mean, I should rotate the game tree to represent well. Usually, I should show the game tree in this way. But in some cases, it's easier for me, it's more convenient for me to draw a game tree in this sense. But I just did that. So again, let's find the players. Let's analyze this game again. Then you can understand more deeply what is it. First, these are nodes again. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 nodes. Okay? And these are terminal nodes, and these are initial nodes. Other than terminal nodes, other nodes represent where players will choose. Who is going to choose? Okay? So, how many players are here? Well, at this node, first player will choose. At this node, second player will choose. At this node, third player will choose. And at this node, again, first player will choose. At this node, first player will choose again. So that there are 3 players. These are pay-ups. First player's pay-up, second player's pay-up, third player's pay-up. So those are pay-ups, including this. Now we need to find what are the strategies. You know, these are actions, okay? These are actions, not a strategy. So we are going to find what are the strategies. Let's look at the easy ones strategies. I mean, here, this is only second player's choosing here, and there's no second player's turn. So second player's strategy is strategy set is T and B. And third player is only here. So third player's strategy here is that U or D. But now, what is the first player's strategy? First, at this node, first player will choose between N or S. If this node is reached, I mean, we don't know yet. We couldn't know, I mean, before starting the game. At this node, once this node is reached, player 1 will choose between N and S. Even though the name is the same, I mean, the name of a strategy is the same, but this does not report to the same action because the timings are different. Because this is happened before and this is will be happened later. So even though the name is the same, but that's not the same. Okay. Again, at this node is reached, then the player will choose N or S. How many strategies, how many actions, no, sorry, how many strategies that the first player can choose? Well, at each different contingency is happened, then player, at each contingency, player will choose an action. Okay? So here, I mean, the strategy set will be derived by find each Cartesian product of these three strategy set. So actually, this is a strategy. For example, here once this node is reached, I'm going to choose S. Okay. Then once this node is reached, still even though I'm choosing S, I'm not sure whether I can choose an action here because the third player chooses U, the game will be end. So that, but still the first player will not know. But anyway, if this node is reached, in any case, player 1 will, let's say that player 1 will choose S. That is the first player's action or plan. Likewise, if the first player chose S, there's no chance to that this node is reached, right? But here, if this node is reached, then the first player will choose S. For example, then that is his strategy because he's showing all kind of plannable action that once that node is reached. If the first character, so we can represent this in this sense. I mean, the first character is represent what kind of action the first player will choose here. For example, S. And let's say that this is the second character is represent what kind of action the first player will choose. For example, here is S. And if this node is reached, there is no chance that this node is reached. But even though the first player just try to choose the S, because of some reason, I mean, because of just the trembling, because his hand is trembling, or maybe his mind is trembling. I mean, he is out of mind. So even though he just tried to choose S, but he just by chance he can choose N. Then maybe there will be a chance that this node is reached. Once this node is reached, then the first player will play S. So this is a strategy. Okay. Likewise, also we can come up with another strategy like S and S. That means this S and S. Right? This is first player's strategies. Or maybe this will be one of the examples that another example of a strategy. N, S, N, S. This is an example of a strategy. Then I'm asking, how many strategies that player 1 have? How many strategies he can, how many strategy does the player 1 have now? Actually, it's 8. Why? If I'm writing here very briefly, for example, SSS, SSN, SNS, NSS, SNN, NSN, NNS, and N. Right? There are 8 kinds. This is first player's strategy set. Also, we can represent this as a Cartesian product, like this. Strategy set of player 1 is Sn times Sn times Sn. Again, this is what is going to choose at this node. This is what is going to choose here. And this is what is going to choose once this node is reached. And this Cartesian product X represent, it makes a combination, with the members from each different set. I'm picking up one member here, then we can generate this strategy set for the first player. So that's the strategy. Okay? Now think about a game when we dealt with in a normal phone game setting. Think about a combination game. Where 2 players are choosing going to Starbucks or Coffee Bean, Starbucks, Coffee Bean. This is the first player's strategy. This is the second player's strategy. And 2, 1, 0, 0, 0, 0, 1, 2. Okay. Now, let's make a tree which illustrate those kind of game. Okay, maybe think about this kind of game. Here, first player will choose S and C, and the second player will choose S and C. Second player will choose here S and C. If both are choosing S, they will get to 1. Otherwise, they will get 0, 0, 0, 0, 1, or 2. Seems like this is representing this kind of game, but something is weird. What is weird thing? In this game, actually, it is not good for you to see quite clearly about this point. So I'm going to use a different slide. Just keep in mind this graph in your mind, okay? So let's move to here. So here, the number is a little different, but let's say that this number is just, forget about this number. Let's say that this is 2, 1, and this is 1, 2. Right? And say that this is the first player and this is the second player. Forget about this dot line. Just forget about this dot line. Then that is, and this is S, C, S, C, S, C. Let's say that. just forget about this dot line again. It seems like this is what is that? This is a coordination game at the first glance, right? Don't you think this is kind of a coordination game, right? I'm going to erase that part just to make you clear. Okay, now you don't see quite well about this line. Okay. So think about this game. Maybe you would think that this is representing a coordination game, but it is not. Why? Because look at these nodes. I will call this node as A, and this one is B. Well, if we think about these nodes, when the second player tries to choose an action between Starbucks and Coffee Bean, you know, player here is, and player here is, it's like they are different. Can you see that? I mean, the second player can choose going to Starbucks or Coffee Bean, Starbucks or Coffee Bean, but it's like A and B are different. What's different? I'm giving you just 1 second just to think about what's the difference between these two nodes. What's different here is that the past is different. Think about that. At node A, well, player 1 chose S, Starbucks. That is the past. The past, right? But at B, player 1 chose C. That is the past. Past are different between those two nodes, right? If I call what's happened in the past is a history. History. Then between these two nodes, history in the past are different, right? Past are different. What it means, at this node, player 2 knows that in the past, first player chose Starbucks. But at this node, second player knows that first player chose C in the past. So the past are different. Histories are different at these two nodes. That's a problem, because when we come up with a coordination game, when players try to choose an action, because they are choosing an action simultaneously, they don't know what the other is choosing. But here, when they try to choose an action, they know what the other chose. That's different. So this game is not representing what representing that coordination game at all. But we have a way to do that. That is, if we are drawing a line here, it represents that the player, second player, does not distinguish which nodes the player is standing. If we want to represent that fact, we are drawing those kind of dot line here. Okay, that is the way. If we add those kind of dot line here, this game is exactly the same as the coordination game. I mean, in order to explain this part, I need to introduce to you a new concept called information set. okay? But to understand the information set, you need to be familiar with the concept and name things. So before doing this, I'm asking you to be familiar with the um, terms like nodes and initial node, terminal nodes, and branch, and what are the strategies you need to be familiar with. Okay, so next time we will do that. So in this week, I'm giving you this very simple quiz about that. Okay, we are stopping here where we will continue about this next week by explaining this information set. Okay, okay, so again, I ask you to understand briefly about this game theory. I will just teach you by extensive phone game, I mean this dynamic game and its application. And after that, instead of looking at deeply about some kind of a math, we will read papers which will be helpful for you to follow these things, okay? And so I'm asking you, um, write a small short paper of which pages should be less than 3 pages. So 3 or 4, something like that. So anyway, I'm going to talk about that part. I'm going to post that part on ULMS soon. Okay, see you later.